Okay. So for this next segment, I'm not trying to tell you anything new. I'm just trying to use in more ways what we've seen already. Right? Of course, you haven't had much time to absorb what we did see, so it may feel new anyway. But I'm hoping at least it feels like it builds on it. So the next example, we've got send. And we have a send that gives us certain kinds of errors. And you know how send works. First it finds the method, and then it applies the method, right? So you can imagine that if you have a loop where you're sending the same method over and over again, that one half of that work gets done the same every time, right? Finding the method every time. So, in the absence of a sufficiently smart compiler, and as TR argued, eventually you always get past the compiler smarts, then you may want to have a form that lets you break it up, where you say, go find the rotate method, so the rotate method out of a point, and bind that to rotate, and then I can call that just like a function, but actually it's a method send. Right? So that's what we want to implement next. We want to implement with method. Right? So we've got things set up here, where I'm building on send, we'll re-export that. We want to define with method. So we can make it a defined syntax rule with methods. And let's see, what's the example again? So we want something like this to work. Let me copy that in. So what with method sees is, even though I have this many parentheses there, I just, for now, we'll deal with one method at a time, right? It's a method name, an object, now actually this is the object expression, and this is the method name, and this is some local identifier that we're binding it to. So with method sees some local identifier. It sees an object expression, and it sees a method name, like that, and then there's an arbitrary expression here. Right, some body expression. Maybe even more than one. Let's let you have any number of expressions in the body. And what we want to do is, if you use local ID in this body expression, then it should act like the method. Right. So is everyone with me? You understand what we're trying to do? So we want to make this something like let rotate be lookup method in a point defined rotate. And then when I use rotate 1 down here, that actually turns into, well, it doesn't quite work out right, because I need to pass the self argument in, right? So I need to sort of get the method like this, but then let rotate be something that takes only one argument. And then calls the method with that same a point and the value. Does everyone follow this? Okay, this is the kind of thing we want to do, and sort of the catch is adding this extra the self argument into the method call. Okay. And also, just from up here, I don't know how many arguments to put here. Right. So there's another idea, which is we could let rotate be a macro that has, that has any number of argument expressions, and then we can do it like this. Okay, and this makes sense if I trust my compiler even less, because I'll make sure that this extra rotate layer gets inlined, and so I really just have the method called directly. How many follow this so far? Okay, so the key is I have this with method macro that I want to expand into a local macro binding. Okay, so I want it to expand to, first I need to look up the method. So I'll let method be lookup method. I have this object expression, but I'm going to need it in two places, right? So I should probably do what I did before. The object is an object expression, is the result of object expression, and now I can use it. So look up the method name. And then where I had let syntax rotate here, or just rot there, that came from whatever the new name was the local ID provided for with method. So I've called that local ID. So it's a macro that matches local ID and any number of argument expressions, followed by a method, and that's the obj with the argument expressions. And then the body expressions. For now, let's just assume one argument actually and come back to this question. Okay. Let's see, I still have an error somewhere. No, up here. So with method expands to nested lets and a local macro definition. Okay, and let's see if it works. So, no, because I forgot to save it. Okay. Okay, works. You can see a small time difference. Looking up a method is not actually that expensive, so we don't expect a big difference there. What if I want to allow any number of arguments here? Like that, right? Except I get an error here. That's because these dots are in this template overall. And in this template, argexpr is not, it's not a pattern variable. So what's happening is ... means repeat things that you matched in the pattern. But I don't mean this pattern. These dots are supposed to be for a different pattern. Okay. So this is a subtle point, but you have to escape those dots. And the notation for escaping is like that. Okay. In honor of backslashes, escaping with multiple backslashes, right? So it's just an arbitrary syntax, but you can see how this going back and forth between the layers can sometimes get a little complicated, as it does for any quoting and unquoting system. But after we fix that, then that's how it works.
Yet another syntax thing. Would I need 3 or 4?
Yeah, good question. Yep. Okay, so it still works out okay. So, there was, like I said, nothing new here, but this idea that a macro expands to a macro definition is quite a powerful technique when you're building up new language forms, because it lets me communicate from the with method macro. It lets me communicate something about this name to the uses without with method going and finding all of those uses manually in the body. Right? So it's a key part of macros communicating across those different expressions. Any question on this? Okay. And the next thing we could do is implement the class macro, and that would get us to this final result. Right, so we have a point class where I just enumerate the fields. I give a name that I want for this. I'll come back to that in a second. And then I just use define all the methods. So this makes it a lot easier to write down a class because I don't have to put the this argument in everywhere. It's implicit. I get to just refer to fields directly. And I get to use what I didn't talk about before, but this is just an assignment on variables. I get to use that assignment form on fields, and somehow it turns into this update of the record. So you can imagine that the class macro is going to need to do the kinds of things we just did, only even more so, right? It needs to communicate to all uses of X that X really stands for a field, and to redirect set assignments to field updates there. Class also needs to recognize all these define forms and change it into, to add an extra argument here, everywhere. Okay. And so, This was written down as a challenge even in the exercises, and all the exercises turned out to be challenged. So we'll just look at the solution here, and just so you get a sense of what it looks like. Right, here's the pattern. Underscore just matches anything, but I could put class there. Okay, so we have a sequence of field names, this ID, and then a sequence of definitions. And you can see I put define here in syntax rules to say really match exactly the word define. Okay. And what we're going to generate is a hash table comprehension where we pair each name with its procedure. The names we draw from the list of method names match here. And the procedures we draw from this sequence of lambdas, each of which is generated from the args and bodies. Right there. Okay, and then you can see I've added this ID as the implicit first argument everywhere. And also inside of every method, I've used define fields, which we implement ourselves in a moment, to map this field name to say, look up the field from the argument this ID. And define field is a syntax ID rules, which lets us map uses of the ID, but also uses with setbang. Right? It makes it cooperate with setbang. So it causes a setbang of a field name and a value to turn into set field with the quoted field name. So you get the idea from this? Right? So this shows a lot more uses of stuff, and it shows a common pattern here of defining a helper macro when we want to take some subpart of the pattern and do relatively complicated things with it. You know, take this body and this field name and combine them in some complicated way using helper macros to do that work for us. Okay. And this macro define fields is not only a helper macro, it turns out to be a macro that defines other macros. Right? So the expansion of define field is a macro definition. When you first start out doing this, it can be easy to get lost at which layer you are. Are you at the macro level? Are you at the expression level? Are you in a template level? Are you in a pattern level? And so that's why there's so much stratification behind the scenes of the different phases to make sure when you do get it wrong, you get an error message instead of some use of an unbound variable or some runtime bug from using things out of context. Okay, so all of this was warm up for the QL language, but the QL language just does this kind of thing again. Any questions on this before I move over to that level language? Yes, so you're going to go first, Boyan?
So how do the error messages look like?
Oh, that's a great question. So let's see, what's going wrong here? Oh, because I went into solutions, so let me take this out to here. Save this as class 1 level up. Yeah. Okay. Okay, so this works. Now your question is error messages, so what should I get wrong? Let's say I do this wrong.
Yeah.
Then in this case, it just says I couldn't match the whole big pattern, so that's not great.
Yeah.
So we would use helper macros or syntax-parse to improve that error message. If I put the number 10 here, then I get an error message from Lambda because of the way it expands. So I think this is a pretty representative example of what happens when you just write macros the straightforward way. You get source correlation, which is fairly useful, but messages that come from down under. And so that's why syntax-parse is there and why it has a lot more support for helping you lift things out. I showed you colon ID, but you can define your own things after colon. Syntax classes, they're called. So that's a whole domain-specific language in itself, right? That's implemented, of course, with macros.
So I was wondering, from a usability point of view, would it be possible to color code separately parts of the syntax and parts of the AST? In a statically typed language like Scala, we would have expr of something or rep of something.
Okay, so the question is, can you color things different colors to help you read the program? So interactively in the editor, doing that requires running the expander all the time. But in fact, we do run the expander all the time, which is why, notice that this V goes to the right arrow, goes to the right place. That's because DrRacket is running the expander all the time. We haven't tried doing that kind of coloring of different phases or different syntactic categories, but it's something we could explore.
Underlining is also nice.
Or underlining, yeah. I think we've tried various things, and you end up with a lot of categories, right? Because this looks like a function definition, but it's a really new kind of thing. It's a method definition. And every macro can come with its new kind of thing. So,
So you would have to set a boundary between what's predefined and you consider predefined.
yeah.
That is actually a macro.
Yeah, so I think what has happened is, in fact, we used to color this define a different color. Maybe if I click check syntax, it does a little more coloring. So if I click check syntax, you can see the colors. Maybe you can tell on the screen. This define became a darker color, and this class is a slightly lighter color. So we do a little bit of that, and I think we haven't found this to be useful enough, especially typing on the fly, to be worthwhile. But it doesn't seem like, it seems like it would be useful if we could make it work even better.
For newbies, for you, it's probably
Yeah,
clear
could be.
already.
Could be, yeah. Yeah, what happens is you get used to not seeing the parentheses, you see the syntactic forms, and you use the libraries where you know what the syntactic forms do.
Sorry if this is off topic, but did you do experiments with people coming new to Racket, how quickly they understand the notation with all the brackets?
Okay, so the question is, did we do any experiments to check how well people understand notation with all the brackets? Sriram Krishnamurthy and his crew, Kathy Fizzler and others, they did some experiments about error messages in teaching languages. So what I'm showing you is full Racket, and then there's beginner student language and intermediate student language. So we've done those kinds of things to refine the error messages. But sort of more generally, how does the syntax, how easy it is to learn and so on. We haven't really done those studies. Anecdotally, I would say parentheses are a real obstacle for 10 to 20% of students in my class. Every language has its obstacles, but that is a particular one in this case. Any other question before I move on? Okay, so we'll go over to QL, where, let me start this in a new window so I can keep track. Okay. So you saw QL. I'll just refresh your memory. We saw an ultimate goal of this form. Not quite of this form. I had #QL at the top, but this is almost there, right? And then we saw, I can find it again. Okay, the parenthesized version of that. Okay, so this is what I want to try to get to. But this example is big. So let's look at this smaller example right here. So this is the smaller example I want to implement. And recall that when I run it, a GUI pops up and things happen when I type in here. Okay, so there's some GUI programming that's not really the point. And so I've implemented that and put it in a library, right? Much the same way that I implemented the raw class system. And I even have a library of operations here because it turns out for these forms, if you don't fill in anything, there needs to be an undefined value associated. And if you add two numbers and one of the fields not filled in yet, then you shouldn't update the field, right? So there's these operations in here that is coercing operations. So this is minus coerce is like subtraction, but if either of the arguments is not a number, then just return undefined so that it propagates through. Okay. So with those 2 bits of runtime support, then we could just write this GUI directly with the raw tools. So I make a GUI, that's the overall window, and then I have GUI add for adding a question to the survey, which is either a checkbox or a number field. Right? In fact, I'm just going to have two kinds at the first. I'll have Boolean checkboxes and money fields for these surveys. So make GUI is provided, GUI add is provided. These widgets that look a lot like the different types of things are provided, Boolean and money. And then GUI add takes the GUI that it should add it to, the widget it should be implemented by, a label for that widget. It takes a guard which says whether that widget should be visible or not. So remember in the larger version, these are only visible if you say that you sold the house. And when you type in the field, it needs to update a variable back. So that's a function that performs the update. And then if we have fields that are computed instead of entered by the user, then we provide a function to compute them. Right? So does this much make sense? When I run it, I get just the two widgets. The first one's Boolean, the second one is money. If you could see, then if I type 12 as the price of the house, then at the end here, selling price would be 12, because that's getting updated through this callback right here. When I typed 12, the widget parsed it as a 12 and sent me a 12 as the value, and it got updated. So our goal is to expand this into all of this. Okay. So how do we do that? It looks like we need a form macro. So let's open. Let's see. I'm trying to remember the right file to open, sorry. Okay, here we go, form 1. So, okay, so I don't have separate modules now. I'm just going to put the macro here and have the use down here. So this again is the same thing that I want to expand to all of this code. So if I want to get this from this, then I need a define syntax rule form, which has the form name, and then it has, well, it has these various clauses, each of which looks complicated, right? Each of these clauses expands out to these kinds of things. And since that's big, I'm going to make a helper macro to deal with that. Okay. So all I have to do for matching a clause is to define that form name to be a make GUI something. And then also have a form clause expansion for each of those individual clauses. Let me pull this part over here. Right? So going from that to this, I want this definition, which is actually form, oh, there's just the form name, right? Okay. Does this line make sense? That's in gray right now? That's because form supplies a form name like box 1 housing, and I want to define that name to be make GUI with the quoted name. Okay, so you're taking care of that part. And now both of these parts are the expansion of this clause, right, which I have deferred to a form clause helper function. So now I've got to define syntax rule form clause, and now I can unpack that more. That's an identifier. It's a question string. And then I think of this as a type, even though I'm writing it as a widget now. So I'll just call it type. Oh, let's call it widget. So this needs to turn into this. So let's just copy that over and then figure out where it should have been abstracted. So it's always define. Where did this name come from? That's ID, right? This name here came from there. And it was always undefined initially. And then it's always GUI add. And where did this name come from? The form name. And where do I get the form name? Where right here do we have the form name? Oh, it's not in the gray part, is it?
We can make those, we can have a function.
Pass it as an argument.
Pass it as an argument. So what if I do this? Like that? Okay, and then I can put it here. Right, it was our helper macro, so we can add extra arguments to the helper macro if we want it. Okay, we have that now. Boolean widget. Just widget. This string. That's question string. A guard. So we haven't written support for the when clauses yet, so the guard is always, the widget's always visible. How about this part? Should it always be lambda v? The widget is always providing us one thing back. It's always a set bang. How about this?
This is ID again.
That's ID. Okay. And then we're not supporting computed values yet, so computed fields. So there we go. And if I take this away,
You need to change the code of clause.
change here. I did form clause, I did add the form name, yes. So we had to change that and then it gets passed along here. Okay. And where did it go? Did I forget something? Oh yes, at the end I need to start it. So how do I start it? I can just put it after all of my form clauses. Right? So in the raw version, we make a GUI, we handle each clause, and then we start the GUI. So I have to change this name to form name, but otherwise it goes. Okay, so 76.76, and if we look at the end at selling price, that's what it was.
How does it know when you put dots in the form clause? How does it know that 3 dots should bind to the
So it's form name, and then a clause. So this part matches form name, and this whole thing in parentheses. Whenever you have parentheses, it groups it as something that matches on a single identifier as a pattern variable. And so this says any number of matches to clause. So this whole thing is a group, and then this whole thing is a group.
And then when you put the macro call from form clause.
Yeah, so these 3 dots,
Exactly.
those are more mysterious, right? So I had multiple matches for clause, so I need to use clause multiple times. And now I had a single match for form name, so what does it mean to pair this value with this sequence of values? Well, it does the thing you hope it would do. It just replicates form name as many times as it needs to match this clause.
So basically it looks on the thing before it
Yes,
and goes and looks, okay, this one had a couple of...
that's right. So just to repeat it so that it's on the recording, yeah. It looks in front of that ... to see what here, and then it looks inside of here and says, okay, what piece of this can determine how many replications we need? And it finds that this is a literal, and this has only one match, and this has multiple matches, so that's the one that drives it.
So maybe another question then would be, what if you have 2?
Yeah, so the question is, what if you have 2 of these?
And you want the Cartesian route.
Right, so what if I match clause and other clause like this, and then I put other clause in here? So what would happen in this case is that we would be constrained to have the same number of other clauses and clauses.
Yes.
Even though that constraint is not in the pattern, it's a constraint to the template. So if you provided different numbers here, the macro expansion would fail saying mismatched count.
So it somehow zips them together.
Right, it zips them together. If you want the Cartesian product, you can't do it in this little language. So you'd have to do helper macros, or break out to arbitrary compile time code. Okay, good questions. Any others? Okay, so this is good. Let's take this with us to make form 2. Okay. Let's see if this is how I want to do it. Okay. Let's look at house raw 2. Okay, the next thing I want to do is support these fields that do have computed values. So I want to make this one work. And what we see in this case is the same kind of thing for the first 3, but in the last one, instead of a false for the compute the value function, I put an actual function there. So GUI add knows what to do. If it sees false, it makes something you can type in. If it sees a function, then it makes something you can't type in, and it has to call this function to update whenever anything else changes in the GUI. Okay. From the pattern matching perspective, what does that mean? It means that we have 2 kinds of patterns for clauses. We have this kind where there's nothing at the end, and we have this other one that has an extra expression. So that means that we want something optional right here, right? But the way we do optional things is, well, we don't do optional things. We'll have to switch to using syntax rules so we can have 2 different cases. So the first case is as it was before. Like this. And then the second case, well, it'll look the same except it'll have this extra expression. And now I'm copying all of this code, right? So how do you avoid copying code like that? You have another helper, right? So we'll have form clause star, which will have the get value function. So we'll always make sure that the clause that comes here has that get value. And then we'll go back and do define syntax. Sorry, this is define syntax rule again. Define syntax form clause, where we use syntax rules. And we have this pattern without the star that has nothing there, in which case we want to pass false. Or we have the part with a, the value expression goes over here. In which case, you want something like value expression here. But do we want, let's see. Over here, I just wrote the expression in our domain-specific language. In the expansion, I need a lambda that wraps that. So the expression can be reevaluated when values change. So that just means I need like that. Okay, so the big picture then is we didn't change form. We replaced form clause with one that recognizes 2 different patterns and defers most of the work to form clause star. And then form clause star is almost the same as form clause before, but we've been passing in the value. And with that, we should be able to do this version of form. Then we have 4, and if I put 10 and 9 here, then they get subtracted as they should. If I made the font big enough, you'd be able to see it at least. But this box says 10, this box says 9, and then it shows a 1. And if I change this to 8, then it shows a 2.
If you change to 20?
Then it would go to a negative number. And if I typed a non-string there, then it would just go blank. I mean a non-number there. It would go blank. Okay, so that's where we were. Where we were trying to get to is here. So what's left? What's left is this when to make things show are hidden. Okay. Does everyone understand what this means? These are some widgets, 3 widgets at the top. Has sold house is a Boolean one, and this says when has sold house is true, then these other things are shown. Okay. So we want to support that. How do we fit this in? That means we have the when clause will show up as a kind of clause here that has nested clauses in it, right? Right, so here's a simple example again, slightly simpler. So has sold house and when has sold house expands to, now we have some new things here where what used to be a function, the guard, which used to always be lambda return true, because the first box is always visible, has now turned into check whether has sold house is true or false. Or maybe it's undefined somehow, so we coerce it to true or false. And has sold house gets pushed down to all 3 of these. So this again looks like we need to have helper macros, but we push down some guard expression. So let's try that. I'll take this. I'll make form 3, where we want this to work. Okay, and why does it not already work? Because I didn't save it? Okay. I think there may be a deeper reason. Okay, so it says bad syntax, and it highlights here, but it really, you can see the expansion of that, it's because of the when clause. So where do we handle when? It's got to be here. So we might have when and then some more clauses. Actually, we have form clause, form name, and then the actual clause that can be when followed by multiple clauses. I mean literally when here, right? So I need to say when is not a pattern variable, it's a literal. How do we deal with that? We should use form clause on all of those nested clauses. Except I need to pass the form name in there. What? Yeah, there should be a condition somewhere, right? So something has gone wrong here still.
When does it need an extra parameter?
Oh yes, that's right. When needs an I. When is some Boolean expression. Right. So it's already running, but the point is it's not doing any showing and hiding because I didn't add any use to the Boolean expression. Okay, does everyone follow? You see why I made a mistake before? I said when in a sequence of clauses, but actually it's when and a Boolean expression in a sequence of clauses. And the point is that Boolean expression needs to get used here. So we need some enable expression here, which will have to be passed in. Which means that it has to be passed in here. Where do we get it here? Well, maybe it's passed in here too. And here, and here, but now this is where I can use the Boolean expression. Right there.
now you're duplicating the expression.
Now I'm duplicating expression. Let's finish it up and then come back and worry about that. That's a valid concern.
And
So when I started off, what's the enable expression?
you are ignoring the first
Yep.
enable expression.
Oh, yes. So, right? So if you have nested wins, then they all need to be true for it to apply. So this might work. Sub window is already active. I saw this error once before. I don't remember what caused it.
Can you close the program?
What?
Can you run two of them at the same time?
Not right now, no. Oh, yes, within DrRacket, yeah. Sub window is already active. It had some. Oh, yes, I remember what it was. I need to coerce to a Boolean. Okay, I don't know how you'd figure that out, but you would step through it and find it. That's what I had to do before.
Why do you need to do it?
What?
Why is this core being used?
Because I initialize everything to undefined, and so when I really meant false, so I need to coerce the undefined to a false, just like I coerce undefined numbers to 0. Okay, so now when we click the box, they show up and they get hidden when we unclick it. But Oko is right. He mentioned that we are duplicating expressions all over the place. And in this program, it's not going to matter because the most complicated expression is just a variable reference. But if I put something here, then it will get duplicated ever. So how would I avoid that?
Wrap a let around it?
Okay, I could try wrapping a let around this. But if I do that, then I'm wrapping a let around a define, and it won't be at the top level.
Just about the Boolean expression.
So I can just put a define here. So so now new guard expert can be a function that has these other things in it. And then I can just put calls to new guard expert everywhere. Okay. So what was duplicating it before was the ... after this gray area. And that would cause the guard expression to get duplicated any number of times, which is bad because it means your program can blow up exponentially if these things get nested.
You're still executing it.
But now we're still executing it many times. Yeah, I'm less
It's not necessary.
you could do better here. That's right. But I need this. The intent of these expressions is that they change results when you evaluate them. So it's just a problem with my overall GUI architecture. It's always just reevaluating things.
Oh,
So I can make the GUI smarter. But as far as macros are concerned, very often when you write a macro, you do need to be careful not to duplicate the expressions. Okay.
right. Well, what would happen if you would actually make this a constant? That would be
If I did just x here and passed x along, then it would get evaluated once at the beginning of the program. And so even when I checked the box, it would still say false.
But not at macro extension. That's the first
Not it.
execution.
Yeah, the first execution. Yeah. So if I do this, then checking the box doesn't work. But if I make it a function so that its value can change, it's not a function, it's a procedure, its value changes each time, then it can work. And if we were to use the macro extepper, we could confirm that it hasn't blown up. Okay. So that was basically the whole thing here for just getting it to run. Where we can keep pushing is on sort of making it nicer, right? So this isn't actually the program I want to write where I write Boolean widget. I just wanted to write Boolean. And this isn't actually the program I wanted to write with minus/coerce. I just wanted to write minus and have those be mapped to the right things. So the way you do that, and I'm just going to start looking at the solutions now. It must be about here. Yeah, the way you do that is you make a module we put the macro implementations in one module and the macro uses in another module. So that would bring us to house 4, right? So it's going to look like this now, where we import our macros, and now I can just say minus and I can just say Boolean, and that's because form 4 renames them on export. So as straightforward as that. Still, I am, if you look at form or house 4, house 4 is written in the Racket language and then it imports the module, which means I can write all sorts of Racket-y things here, right? I have cons and map and for and all those things. What if I want to constrain the sets of syntax that are available in this language, right? In that case, what I want to write is more like house 5. Okay, so what this lang line says is I'm still using S expressions, but now instead of pulling at all of Racket, only give me the bindings that come from form 5. And form 5 is not going to give me lambda or map, so I can't use those here anymore, right? Or write infinite loops or things like that. Okay? And if we look at how form 5 is implemented, then again, it's still exporting the stuff that it exported, but it also needs to export the things that we do care about from Racket. And it turns out there are these weird #% names that you've been using all day and you didn't even know it. Right? These are some implicit macros. So whenever you write a function call, you're implicitly using the #% app macro. So if you want to implement a lazy language, then you can just change the application form to be lazy application. Right? We didn't want to do any of those kind of things. We wanted just regular application. So we pass in the regular one. And similarly, when we write down 17, it becomes 17 implicitly quoted because of the #% datum implicit macro. So we could change that, but we don't need to. And #% module begin means we could do a whole module check before, it's implicitly wrapped around the whole module. So that for something like typed Racket, it uses #% module begin to type check the whole module, globally for that. For that whole module at least, not globally, but across modules, but that's what it's used for. And then finally, we were using the when keyword, so that needed to be passed out. Okay. So this module then provides everything. It doesn't have to be added to Racket. It provides everything that you need to run the language, and so it's more confined. Let's see, what are we trying to do? Okay, we can do the same sorts of error checks that we did before, where if I put a string here instead of an identifier, then we get a good error message. You know how to do that, though, right? That's just using syntax-parse instead of regular pattern matching.
So you ended up importing the when from the language as well.
That's true, and so I could still use when, right? So what if I wanted to disallow that? Then what I would do is not export when, but I would rename out when star as when. So good catch. I did provide when so that could be used in any expression. But if I export when star and then I change this macro to match when star there, and I did it in a different order before, I guess, here. And then I can define syntax when star lambda syntax to always raise an error. So if you ever try using it in an expression position, this macro will get triggered and complain, but I can still match it literally.
What does S-expert contain?
So the question is, what does S-expert contain? And that is just, it's no macros, that's just the parsing of parentheses and identifiers and strings and numbers and so on.
Okay,
So it takes this, recognizes parentheses and comments in the usual way, wraps it in a module begin, and ships it off to this module. Good question? Any other question? Okay, so we know how to do those kinds of checks and provide good error messages there. But what if I try to subtract selling price and has sold house, which is a Boolean? So, in other words, what if I want to do something like type checking? Okay. So, that is going to require some compile time work, but it's also going to require some communication between the macros, right? This clause will need to identify selling price as being the money type. It needs to sort of map this name to two things: selling type as the money, selling price as the money type, and selling price as a variable whose value can be used at runtime. And then how does minus know that selling price is of type number? It's going to have to look up, at compile time, look up information about selling price. So it needs 1/2 of that information. And then what if I nest minus inside of plus? Well, you can sort of globally type check all of these things, or what you can do is arrange for the expansion of selling price. It should expand to has type selling price Boolean, money, I mean. So we're going to make macros expand to bigger things where, and then when I have this initialization expression like this, that's going to a money, I will need some sort of check type to make sure that has money. And selling price is going to expand to a has type, and so on and so on. And so these macros should be able to cancel each other out. And when they don't cancel properly, then they can complain. Right? So I'll show a little bit more about that, but I think there was a question first. Question?
No, it's just spelling mistake.
Oh, okay. Yeah, thank you.
There is a question, actually, where do you take the minus signature from? Because you would also have to have the signature minus.
That's right. And so I haven't done enough yet here. There needs to be a has type. This minus expression is money, and so on. So we need more of these has types and check types. So I just wanted to give you the high level idea, and what we will need. It's over here actually. So we're going to end up with this check type macro that has an expression and an expected type. But the expression is just going to be a number or a reference to a variable or something. We need to get the expanded version of that. So this is the first macro that I'm trying to write that's kind of upside down. Usually we want to expand from the outside in. But for this macro to work, we need to expand a sub-expression first so we can look at it and see if it declares a type. Right? So that gets you to pretty advanced macros, right? Macros that are extensible type checker macros. Okay? But if you need to do that, then there's a new part of the macro expander that I haven't talked about called local expand. And that just forces expansion on this sub-expression. Okay? And we need to expand it far enough to see has type, and then we can check and see whether there's a has type. Right? And the other part of the story is I need to declare variables to have a particular type. And that's defined typed here, which defines an identifier to be a compile time thing that has its type that redirects to a runtime thing that has the actual value. Okay. So when you get to this level, then these different phases and the separation of phases come into play, and knowing at which time things run. And part of my implementation here needs a record to combine an identifier with a type. And so that's compile time code. And so it sits under begin for syntax. So it's a compile time function that's available for use in macro implementations. Okay. So I won't go into that any more detail than that, but once you have that part of the type checking support, then
Can you maybe show us exactly where you store for a value its type? You should have a hash map or something hash maps that you put for its scope.
okay, let me try to show you through this. I think this is the right one. That's not the right one. Okay, it's T1. Okay. So this is where it's stored. I used to say define value, I define ID undefined. Now I say define typed ID, which expands to define syntax of ID that stores this type with that identifier. And it also makes this identifier a macro that rewrites itself to this value.
Okay.
Okay. So that's the declarations of types get attached to identifiers, or they get attached to expressions. And then where I had this coerce before, now I'm going to actually add a check type wrapper around it that checks if this expression expands to something that declares itself to be a Boolean type. Okay. And it goes on for just a little while from there. I think we have to do something with the primitives here. So I define minus/typed, which declares itself to be a money type when it does a subtraction, while also checking its arguments. Okay. Okay. So each of the minus, less than, greater than, it's this kind of pattern. So of course I have a macro, so I don't have to write all of those macros that look the same. And then what we export is minus/typed. So, okay. So that gives you the idea of how you can do more arbitrary, non-local checks among things inside a module or even across module boundaries. And I think that's probably a good place to stop. Okay. Oh, I didn't do, all right, 2 more minutes. So I'll just show you how then did we get to this final step. Now you can see instead of hashlang S expression, it says hashlang reader, which means go consult that module to even figure out how to parse. And then if you go look inside that module, you'll see a Lex and Yak kind of thing, which recognizes curly braces and strings and turns it into parenthesized things, and then the macro layers take over. And what that really illustrates is a strategy for building languages even without parentheses. What works well for us is to build the parenthesized version and then have a thin layer to deal with a different concrete syntax that converts into the parenthesized version. And then we have all the macro machinery to go from there. Okay. So now I'll just take any more leftover questions. Okay, great, thanks.